Hey guys, it's Austin Chen, and today I'm going to be going over the first 5 problems of the 2020 AMC 12A. You can find a link to the problems in the description of this video, but the problems will also be displayed on screen. If you have any questions, you can comment in this video or you can email us at lubbockmathclub@gmail.com. Alright, let's go ahead and get started. So the first question, we have Carlos took 70% of a whole pie. Maria took 1/3 of the remainder. What portion of the whole pie was left? Okay, well, if Carlos takes 70% of the whole pie, that means after Carlos takes that 70%, there's going to be 30% of the whole pie remaining. Now, Maria is going to take 1/3 of this remainder portion, and we know that this remainder portion is 30% of the whole pie. So if she takes 1/3 of that, she's taking 10% of the whole pie. If Carlos takes 70% of the whole pie and Maria takes 10% of the whole pie, that means together they'll take 80% of the whole pie. That means there's going to be 20% of the whole pie remaining, and our answer is C. Now, the second question, the acronym AMC is shown in the rectangular grid below with grid lines spaced 1 unit apart. In units, what is the sum of the lengths of the line segments that form the acronym AMC? Okay, so we have to find the length of all the line segments that form the acronym AMC, and we have to total them out. So one way you can do that is to find what the lengths of the types of lines are, and there are 3 types of lines. The 3 types of lines are horizontal. The 3 types of lines are vertical lines, horizontal lines, and diagonal lines. So it tells us that the grid lines are spaced 1 unit apart. If the grid lines are spaced 1 unit apart, the horizontal and vertical lines must be 1 unit of length, and that's because they're on the grid lines. Now, the diagonal lines are not going to be 1 unit long because they're formed by a vertical and horizontal line, which are 1 unit long, right? So because this forms a triangle, and this is going to be a 45-45. This is going to be a 45-45-90 triangle because this diagonal goes in between a square. And when you have a diagonal going in between a square, it's going to cut off this angle in half, right? And because this angle is 90 degrees, we're going to have 45 degrees here. So if this is 45 degrees, and this is 45 degrees as well, we have a 45-45-90 triangle. And that means the diagonal side is going to be √2 times one of its legs. And because one of its legs is 1, that means its diagonal is going to be 1 times √2, or just √2. You can also figure this out by the Pythagorean theorem. 1 squared plus 1 squared is going to equal 2, so that must be √2. So we know the length of our diagonal line is √2 units. And now we just have to count how many horizontal, vertical, and diagonal lines there are. And so, for each horizontal and vertical line, we'll add a 1 to our total. For each diagonal line, we'll add √2 units to our total. Now, I'm going to save you the counting, but, hopefully you guys can count. But so when you add them up, you'll find that you have 13 horizontal and vertical lines. So that means you'll have 13 units for horizontal and vertical lines, and you'll count 4 diagonal lines, which means you'll have 4 √2 units for the diagonal lines. Now you just have to add them up, and you see that answer choice C is our answer for number 2. Now, let's move on to number 3. A driver travels for 2 hours at 60 miles per hour, during which her car gets 30 miles per gallon of gasoline. She is paid 50 cents per mile, and her only expense is gasoline at $2 per gallon. What is her net rate of pay in dollars per hour after this expense? So there's kind of a lot going on here, but let's figure out what we're trying to find. So it asks us, what is her net rate of pay in dollars per hour? So if it asks us for her net rate of pay in dollars per hour, that means we don't care about how long she's actually like driving or doing this, because we're not finding the total, we're finding it per hour. So the first bit of information travels for 2 hours, so we don't care about that. But then it says they're traveling at 60 miles per hour, and her car gets 30 miles per gallon of gasoline. So if she's driving 60 miles per hour and she gets 30 miles per gallon of gasoline, that means per hour she'll need to use 2 gallons of gasoline, because those 2 gallons of gasoline will be for her 60 miles per hour that she's driving, right? So she'll have to pay for 2 gallons per hour. I'll just say 2 gallons per hour. Okay, and she's paid 50 cents per mile, and her only expense is gasoline at $2 per gallon. Okay, so if she's paid 50 cents per mile and she travels 60 miles per hour, that means she'll get $30 per hour for driving 60 miles per hour. And her expense is gasoline at $2 per gallon. We already found out that she needs to use up 2 gallons per hour. So she's using up two gallons per hour, and they cost $2 per gallon. She's going to be using up $4 per hour. So now we have she's gaining $30 per hour, she's losing $4 per hour. You add this up, and you'll see that she's gaining $26 per hour, and this is what they're asking us for. Her net rate of pay in dollars per hour. This is going to be $26 per hour, and the answer choice is going to be E. Now let's move on to the fourth question. How many 4-digit positive integers, that is integers between 1,000 and 9,999 inclusive, having only even digits, are divisible by 5? Okay, so let's figure out what they're asking us. They're asking us for how many 4-digit positive integers fit this kind of constraint. And so the part where it's saying integers between 1,000 and 9,999 inclusive, that's just saying where it's defining 4-digit numbers. But so like we don't really care about that. So let's figure out what constraints we're dealing with. So the integers that we have to have only even digits, and they have to be divisible by 5. So why don't we work with the divisible by 5 portion first? So a 4-digit number is going to have 4 digits. And if a number is divisible by 5, it has to end in 5 or 0. So this last digit must be 5 or 0. But the other thing we're told is that the number has to have only even digits, which means that 5 is immediately crossed out because 5 is an odd number, but 0 is an even number. So that means our last digit must be 0 for it to be divisible by 5 and for all its digits to be even. Now, the constraints for these 3 digits, the only constraint we have is that they have to be even digits, because because this last digit is 0, it's always going to be divisible by 5 no matter what digits we have here. So now we just have to make sure that these digits are even, and we count how many possibilities there are. So let's figure out how many even digits there are, right? So there's 0, 2, 4, 6, and 8. So there are 5 even digits. So, if there are 5 even digits that you can put in for all of these, it seems like our answer is just 5 times 5 times 5 equals 125, but it's actually not, because the first digit of our number cannot start with 0, right? Because, if you have like a 0, 2, 0, 0, that's not a 4-digit number, it's a 3-digit number. So we can't have the digit 0 as our first digit, which means that our first digit has only 4 even digits that it could be. So that means our first digit will have 4 choices. Now, we know that our first digit has 4 choices. We know that our second digit has 5 choices. We know that our third digit has 5 choices, which means that to figure out the total number of choices for our entire 4-digit number, we can just multiply these numbers together. And, we have 1 choice for our last digit. So we can just multiply these numbers together to get the total amount of permutations that we have for our total number. So that's just 4 times 5 times 5, and that's going to give us 100. So the answer to number 4 is going to be B. Now, number 5, we have the 25 integers from -10 to 14 inclusive can be arranged to form a 5 by 5 square, in which the sum of the numbers in each row, the sum of the numbers in each column, and the sum of the numbers along each of the main diagonals are the same. What is the value of this common sum? Alright, so it seems like it has some kind of magic square. So I'll go ahead and draw it out. So we have a 5 by 5 square that is going to look like this. That's a really bad square, but just imagine it to be a square. But anyway, so it seems like we have like some sort of magic square, right? The sum of the numbers in each row, the sum of the numbers in each column, and the sum of the numbers in each of the main diagonals sum up to the same number. And in each of these boxes, there's going to be a number from the set of 25 integers from -10 to 14 inclusive. So there's a clever way to solve this problem, and that it's that, we know the total sum of the entire square. We know the total sum of the entire square because we're given all the numbers that are in the square. So we can find what the actual total sum of the square is. And so because we know that amount, we can try getting what we want to know. We can try adding up the values in our magic square in a clever way so that it equals our total sum, which we know, but it also comprises of the common sum that we want to know. And so like what I mean is that we can take each of these rows. Now each of these rows sum to a common sum, right? So I'll call this common sum x. If we take each of these rows, they'll all sum to this common value x. Now, if we sum all the rows, we'll get 5x here. But we also know that if we sum all the rows, we're summing all the values in the entire square, and we're only summing them one time. So that means this is going to equal, 5x is going to equal the sum of total square. And x is just what we want to figure out, right? And we can figure out what the sum of the total square is. So now we're on track to actually solving the problem. So now we just have to figure out what the sum of the total square is. And we're given that the numbers in the square are the integers from -10 to -14 inclusive. So these are going to be the integers in our square, and we need to find the sum of all of these. Now you could sum these like one by one, but that will take very long. And an easier way to sum these is that we can pair off the negative integers with the positive integers. Like we can sum -10 and 10, we can sum -9 and 9, so that they cancel out, right? So if you have a negative number and a positive number that are the same magnitude, but they're just negative and positive, they're going to cancel out, right? So all of these negative numbers and the positive numbers 2, 10 are going to cancel out, right? So then we're just left with the positive integers from 11, 12, 13, and 14. And so the sum of these is going to be 50. So that means we have 5x equals the sum of our total square, which is also 50. And that means we can solve for x as 10. And this is the value of our common sum, which is what we want to find. So our answer is x equals 10, or answer choice C. Alright, that's it guys. Thanks for watching.